Let's talk about how to solve a proportion. An important part of being able to solve proportions is understanding fractions. So before we get started on the lesson, let's do a quick warm-up on identifying equivalent fractions. We're going to figure out which of the fractions on the screen are actually the same fraction, 3/4. That fraction is fully reduced. I can't simplify that any further. Whereas 21 over 28, that fraction is reducible, because both of those numbers are divisible by 7. If I divide 21 by 7, I get 3, and if I divide 28 by 7, I get 4. So I could rewrite the fraction 21/28 to be 3/4 instead, which means the first two fractions are equivalent. They're actually the same thing if you reduce. But remember that in order to reduce, you have to divide, not subtract. So just because I could subtract 1 from both of these numbers on 4/5, 4 minus 1 would be 3, 5 minus 1 would be 4, that's not how reducing works. So 4/5 is not equivalent to the first two. What about 15 over 20? Well, yeah, they're both divisible by 5, so I could reduce that to 3 over 4 as well. So this one is equivalent to the first two. And 30 over 40, yep, that definitely reduces to 3 over 4, so that's another equivalent fraction. 8 over 6, well, they're both divisible by 2, so I could reduce this to 4/3. But 4/3 is the reciprocal of 3/4, and therefore it's not equivalent. 13 over 14, while it has a 3 on top and a 4 on bottom, you can't just reduce by getting rid of the 1 in front of each of those numbers, so 13/14 is not equivalent to 3/4. 27 over 36, well, they're both divisible by 9, so I could reduce that to 3/4 as well. What about 1.5 over 2? It's pretty rare to see a decimal in a fraction, but it does happen. So if you're trying to simplify this fraction, you're actually going to make it bigger, not smaller. Instead of dividing both of those numbers by something, you're going to multiply both of those numbers by something. What I would multiply by to get rid of a decimal like 0.5 is 2. Basically, I'll double the top and double the bottom. And if I do that, I get 3/4. So even though it was a rather strange looking fraction because it had a decimal in it, it is equivalent to the others. All right, now that we've warmed up our fraction skills, let's get started on the lesson. For this whole unit, we're going to be talking about ratios and proportions. A ratio is basically just another word for a fraction. Sometimes you'll see a ratio written with a semicolon instead, but it's really all the same thing, A over B or A to B. Typically, we express ratios in their simplified form, so instead of 6:8, we would say 3:4. And a proportion is when you set two ratios equal to each other. For example, A over B equals C over D, that would be a proportion, because it sets the ratio A over B equal to the ratio C over D. We can solve equations that look like this with the cross-multiplication property. The cross-multiplication property says that you can multiply the numerator of one fraction by the denominator of the other, and set that equal to the denominator of the first fraction times the numerator of the second one. Let's see that in action. We're going to solve this proportion for x. In order to do that, we're going to multiply x times 18, and we're going to multiply 12 by 6. So I get x times 18 equals 12 times 6. Simplifying that, we would really write that as 18x, not x times 18, and 12 times 6 is 72. So I can divide both sides by 18 to get my answer of x equals 4. Let's try another one. We're going to multiply the top of one by the bottom of the other, and the bottom of one by the top of the other. Let's take a look. 5 times 48 equals x times 40. Simplify, probably need a calculator for that one. 240 equals 40x. Divide both sides by 40, and I get an answer of x equals 6, which means 5/6 is equivalent to 40/48. Not all proportions have just a plain old x though. Sometimes you'll see more complicated proportions like this one that shows x plus 4. The cross-multiplication property still works though. I'm going to multiply 24 times x plus 4, and I'll multiply 36 times 8. Keep in mind though that since this denominator had two terms, we're going to have to distribute. It's not just 24x plus 4. It's 24 times x plus 4. I have to distribute. So 24 times x is 24x, of course, and then 24 times 4 is 96. And 36 times 8 is 288, so to continue solving I need to subtract 96 from both sides. 288 minus 96 gives me 192. And my final step would be to divide both sides by 24, so x equals 8. Which means if you were to plug that back in up here, 8 plus 4 is 12, so 24/36 is equivalent to 8/12. Let's try another one. X minus 8 times 42 and 7 times 12. It can feel kind of weird to distribute backwards, but that's what we're going to have to do this time based on how my proportion was set up. Since this numerator had two terms, I need to multiply both of those terms by 42, and it happened to be that the 42 ended up after those two terms. So you're going to multiply x times 42, and you're going to multiply negative 8 times 42. So you'll get 42x minus 336, and then 7 times 12 is 84. Our next step would be to add 336, and finally divide by 42 to get my answer of 10. So plugging that back in, 10 minus 8 is 2, so 2/7 is equivalent to 12/42. Our next problem is the most complicated to solve for because we have two variables. So let's see how this plays out. The cross multiplication property still works the same way, even if it's a more complicated problem. So I'm just going to multiply 13 times 4x plus 1 and multiply 2x minus 3 times 39. So we do have to distribute on both sides of the equal sign because we had two terms and two terms. So we'll distribute 13 forward, which feels pretty normal. 13 times 4x is 52x, and 13 times 1 is just 13. And then we have to do that weird distribute backwards thing again over here. 39 times 2x is 78x, and 39 times negative 3 is negative 117. Now let's get our x's together on one side. I'm going to subtract 52x from both sides and get 26x. Then I'll add 117 to 13 to get 130. And finally divide by 26 to get an answer of x equals 5. That was actually probably mostly just a review of middle school. You should already know how to solve proportions before you arrive in geometry. So let's use these skills to solve geometric problems. We're going to use proportions to calculate a missing side length in this triangle. To begin, we're just going to fill in each of the lengths that we're told on the diagram into this proportion that we've been given. So first I need AB, which is 24, and I'll put that over DE, which is 16. And I'll set that equal to BC, which is 33, over EF, which is what I'm looking for. I don't know the length of EF yet, so I'm going to leave it as x. So, since it's a proportion, I can cross multiply to solve. 24 times x and 16 times 33 gives me 24x equals 528. So I can divide both sides by 24 to get my answer of 22 meters. So EF must be 22 meters long. Alright, that was pretty easy. Let's try one that's a little bit more challenging. It's the same idea that we're going to look for a missing side length in this triangle by filling in numbers into a given proportion. Let's take a look. GI is 18, and GK, well, that's actually this entire side length. It's not just 18 and it's not just x, it's both 18 and x. So I'm going to add those two expressions together. This whole side length is x plus 18 feet long. And I'll set that equal to HJ, which is 16, over HK, which again is this entire side length. It's not just 16 and it's not just 24, it's the entire 16 plus 24 side length, which would be a total of 40 feet. So let's cross multiply. 18 times 40 equals x plus 18 times 16. Don't forget to distribute when you do this. It's 16 times x, that's how I got 16x, and 16 times 18, that's where I got 288. And 720 came from 18 times 40. Then I'll subtract 28 and divide by 16. Hopefully that part of solving equations is easier in geometry. Hopefully solving equations is manageable by now. And you get an answer of x equals 27 feet. So this little part of my diagram is 27. And that's the basics of what you need to know about solving proportions. In our next lesson, we're going to develop the idea of what it means for two polygons to be similar and how we can apply ratios and proportions to that idea.